All right, everyone. In this video, we are going to go over the remaining steps of the scientific method that we haven't discussed yet. So we're going to start with learning about data table setup, and we'll talk about graphing. Then we'll talk a little bit about what to write in a conclusion. So if we begin here, how do you set up a data table? This is an example. And sometimes your data table could be more simple than this, and sometimes it will need to be a little more complex than this. But this is a generic example. A data table should have a title above it so you understand what data it is collecting and showing. Typically, we can write something in the form of this sentence stem here, the effect of what on something else. So if I was to use an example of an experiment, trying to find out if screen brightness of an iPad affects how long students can pay attention and stay focused, I would title this "The Effect of iPad Screen Brightness on Student Focus or Student on Task Work." Okay, so then in your data table down the left side, you will list your independent variable. So I might test full brightness, 75% brightness, 50%, 25%, and I don't know, 5%, because zero wouldn't work. Then the dependent variable, what depends on the outcome or what I'm going to measure that depends on it, is how many minutes students can stay focused. And I should do multiple trials, right? We've talked about this so that I know my results are a little bit more valid and accurate, not just a one-time fluke. And at the end of our data table, often it helps to calculate the mean or the average so that we can easily compare single data points. In writing a procedure, as we think about how to set up our experiment, you as the experiment designer and scientist will think about what steps do I need to do, what quantities of materials do I need, how should things be set up, etc. The guidelines here say make it a numbered list of directions. Okay, so first you should, all right, and then next do this, and third take the 20 milliliters of this, etc. So you're gonna make it easy for a person to follow and know that they've completed each step. Often it can be helpful to include a picture or drawing. Maybe you would draw out a graduated cylinder showing a certain quantity of liquid so that they can visualize what they should be doing. Maybe you're going to explain how the Bunsen burner or show a picture of how the Bunsen burner might look when it's correctly set up. Be sure to use specific names of materials and tools, and be sure to use quantities and measurements of materials and tools. In talk about anything that should be kept constant in your experiment so that it doesn't change the outcome, and then tell also how many times to repeat. Make sure it's detailed enough that someone who is not doing the same experiment as you would understand how to do it in full. In order to graph, right, a graph is a good way to visually show the results of an experiment. So typically, so that a graph doesn't become too busy with too many things on it, we're going to graph the averages of our results. So from your data table, you can take that information and then put it onto your graph pretty easily. A graph should always include three things: a title, again, similar to probably your title of your data table. The independent variables, if you're doing a bar graph, for example, will go along the bottom, the x-axis, and the dependent variables, including units, right, so that people understand how it was measured. Dependent variables should go along the y-axis. Okay, and then the final piece of your scientific method process will be to write a conclusion. Okay, and a conclusion kind of has four parts. So first, you'll need to analyze or interpret the data that you collected from your experiment and summarize the results. In your writing, you can see the red text example here. You will need to use data, numbers, and units. Talk about the dependent and independent variables and how they resulted. You may even refer to the graph that you have or the data table that you have in this writing. But at this point, keep it simply factual. Notice in this example, it doesn't say anything about I think because or that means, right? It's just saying what the results were factually. So here's another example that kind of refers to the lines on the graph, talking about temperature change and how the results came out. Next step is to talk about whether or not the hypothesis was supported. Okay, so we don't often in science say that something is proven, because in order to prove something, we would really need to test every single possible way that something could happen, and that's not very very doable. So we say our hypothesis was supported. So far, we have data that supports our educated guess, or we talk about how it's not and explain maybe why that was the case. So in your conclusion writing, you'll again here you could say, see in the red text example, the evidence shows that the hypothesis was supported. The hypothesis predicted that plain water would fit the most number of drops on the tail side of a penny. See how specific that writing is, right? It even talks about which side of the penny. Um, then you're going to again use data, right? So that you someone who's reading it can understand and see clearly, yes, there is evidence here to say that this is the case. Next, in your same conclusion paragraph, all of these sentences for the conclusion kind of go together. You're going to discuss two possible sources of error. What could have affected the results, or made your results inaccurate, possibly? And why might each trial that you did of the experiment have given you slightly different results? What might have caused that? And then finally, explain why that you think that was the case or how that affected the outcomes. So you see a couple of not good examples here, right? We need to be more detailed. Um, Something like the seal of the Ziploc bag may not have been tight enough. Some gas may have escaped. This could have affected the results because the mass would have been less, etc. You can see in our data table, in fact, the mass in the Ziploc bags varied from zero point 0.3 to 1.6 grams. Um, Another example here, the bottle of vinegar had been opened for 9 days, and we wonder if it had lost any of its effectiveness over time. Reason we believe this is because we saw leftover baking soda in the liquid of our graduated cylinder each time we did the experiment. All right. And then finally, the last step of your conclusion writing is going to talk about any ways you could improve the experiment if you did it another time, right? How could you be more accurate or complete in the way that you conduct this experiment? What might you add or do differently or do more of or do less of that would better show the results you're trying to show? So, again, a not very good example is to be very brief and just say something like, I would follow the instructions. You want to be specific. You maybe even want to use some data again, in order to explain to someone who would be reading it what would you need to do differently. All right, that's it for now.